Okay. Uh, we'll go through the paper 3 first, and then whatever time we have left, we will do other stuff. But I do think you guys are luckier this year because I feel this year's paper 3 is easier, right? But you don't make careless mistakes, lah, right? Okay. So I would quickly just go through the general guidelines first before I go through what I think you might want to focus on a little more. Okay. However, I do not have a crystal ball. I do not know if this is what will come out exactly. They can change the question. A good student would study a bit more. Okay, that's all I would say. Right? Don't just study one thing. Okay, so as you open the paper 3, you just have to read. I think you guys have done it many times. Just read the question carefully. What they ask you to investigate will be very clear. Normally, the aim can be found in the question, which will contain MV and RV, your manipulated responding variable. Okay. You know this already, but manipulated variable is what axis on the graph, guys? X, and responding is Y. Okay. So your paper could be guided or unguided. My feeling, just a feeling, that this year might lean towards a guided experiment, just because it's a little hard for you to create one that is unguided. However, I'll still teach you how to write the procedures for this experiment. Okay, no worries. Okay, so unguided means you plan out and write your procedures yourself. Okay, so one quite important thing is whatever variables you write could be your manipulated, responding, controlled variable, or fixed variable, must be something that can be measured. And this will be a bit different with physics and bio, because I think in physics in chem and bio, I think in chem or bio, you can write type of stuff. Type of stuff should be okay. But so whatever I'm saying is for physics, chem and bio, you go and check with your respective teachers. Okay, like we don't say amount because amount is something you cannot measure. It's too vague. So instead, you write things like mass or volume, right? We don't want to say size. Like what is size, right? You say length, diameter, area, volume to represent size instead. Yeah? Instead of saying type, so if you're talking about different types of spring, instead say the spring constant, the different spring constant. Don't say type. Type is again too general. If you're talking about different wires would have different resistivity. Use the word resistivity instead, right? Or if you're talking about different metal blocks, let's say you're doing a heat experiment, then you say specific heat capacity of the different blocks. Don't say different type of block, too general. Okay. You will probably be asked inference and hypothesis, which I think is 3 marks, because you just have to follow a format, right? Where you say RV depends on the MV. Normally, we prefer this one. RV depends on MV. Just copy your RV. For example, buoyant force depends on depth of whatever objects immersed. For example, okay. You can also use the affect one, but I prefer the depend one. Okay, usually the papers prefer the depend one. Then hypothesis is the greater. Okay, be careful that for inference RV counts first. RV is the one depending on the MV. Responding depends on manipulated. Hypothesis is the greater, the smaller. Then constant variable, same stuff. You don't write things that are too general. Okay, and the best answer would normally come from something that can potentially affect your responding variable. So, students, they will ask can I write this? Can I write that? Well, some marking schemes will have multiple answers for constant variable. Some marking schemes will only accept one, right? So now we talk about buoyant force, right? You think a bit about the one directly affecting buoyant force. Best answer that affects your RV is density of the liquid. So density of water. That would be the best answer, if you ask me, because it's right there in the formula. Some will say, teacher, can I write gravitational acceleration? Can lah, but not the best answer unless you do your experiment in the moon or in Mars, for example. Okay, then the G value might be affected, but it is a second choice, not the best choice. You get what I mean? Something that can directly affect it, that'll be the best answer. Okay. And when it comes to procedure, how you get your 3 marks, your first mark, second mark, third mark, is by making sure that in your procedures, so can you help her? Hello? Oh, ah! Don't worry. Don't worry, don't worry. You go. Okay, back to here. So just make sure that as you write your procedures, if it's unguided, to make sure you have these 3 things. How to fix your manipulated variable, how to fix your depth, for example. How to get your responding variable, how to get your buoyant force, please explain. And then repeat your experiment with 4 other manipulated variable readings. So in total, you will have 1 and 4. So total, you have 5 readings minimum. Minimum is 5 lah. Yeah, we normally just do 5. You want more also can, but minimum will be 5 readings. Okay. Now, after doing your experiment, there comes the table part. I feel the number of decimal places is not so important as compared with the consistency. Okay. Do not stress about the number lah. You use your ruler. Let's say you use a meter ruler to measure something. If maximum, you can read up to like 22.3 cm. Then everything will be 1 decimal place lah. Okay. Some of you will say, teacher, what if I'm able to read, okay, let's say this is 22.3 and 22.4. My measurement is so happen right down the middle. Can I put 22.35? Is that okay? That's fine. Then everything in your column, make sure is 2 decimal place. So don't go and memorize the decimal place. You just look at whatever you are using. If got 1 decimal place, then you put 1. Everything 1. 1 decimal place all the way. If 2, then everybody 2. Right? So you don't want to make mistakes like this. Like for example, okay, first value you get 2.79, for example. Let's say this is buoyant force. This one just example. And also you want to put down your symbol, if there is a symbol. You follow the question, maybe the question say FB. You also want to make sure there is a unit. No unit, no mark. No unit, immediately lose mark. In your paper 3, it's all these small things. The paper 3 is not hard, but a lot of small parts will get you to lose mark. The whole table can cost 5 marks sometimes. Can sometimes cost 5 marks or 4 or 3, depending. Okay. Then, for example, like 3.5, and then sometimes you have a value like, let's say 4, let's say 4.9. All this you need to go and add yourself. Consistent, just make sure you are consistent. Table can be 3 to 5 marks. If 2, then everything 2. If 1, then everything 1. If 3, then everything 3. Okay? Your teacher say probably buoyant force coming out. Yeah, I'm doing buoyant force. Okay? All right. Then next part is drawing a straight line or a curve graph. Now, you don't need to worry about this year's. I feel you do not need to use a curve because last year was a curve. Last year's one was a curve. That's why I say last year's one was harder. Okay, this year we're expecting a straight line. You don't have to pass through all the points, but minimum 2 lah. Okay, minimum 2. And please make sure you balance above and below the line. So, for example, there are some points slightly higher, slightly lower, and these 2 pass through. Minimum pass through 2. The rest, some is higher, some is lower. I don't want you pass through 2 and everything is below like that. This is not a best fit line. Okay, This is not a best fit line. And sometimes you all get very excited to put the points. So you happily go and put, let's say depth is H, or maybe they use D, I do not know. Then you put FD. And then, okay, let's say you put down the scale. What is missing still? Before I start plotting, what is missing? The units. I want you to know that if you never even plot any points, the unit will already give you marks and the proper label and the proper scale. Like that already got marks on, sometimes 1 to 2 marks. You haven't even started drawing. Sometimes 1 to 2 marks. So can you please make sure that this part you don't lose marks first? The unit is super important. You want to make sure you have the units. Okay. Yes, Joseph, you got a question? No? And graph must be more than half the paper. Okay, more than half the paper. Okay. Now, after you draw the graph, confirm they will ask you relationship. Yeah. Okay. Okay. Ask you your relationship. Now the thing is, follow your graph. Follow your graph, not the theoretical relationship in the textbook. Okay. So we are expecting that this year most probably is directly proportional, right? Directly proportional, which means will look like this. But what if your points really, really look like the increased linearly one? Can get marked or not, you think? Yeah, can. This one, correct. If really your one is floating on top like this, can or not? Can. There is nothing wrong with this graph. Guys, the purpose of paper 3 is what? Not to test your paper 2 knowledge. Paper 2, I'll test another way, right? Paper 3 is just to see whether you know how to analyze your own experiment and get a result, get a relationship out of your own graph. Both are correct, huh? This year's SPM. If you draw directly proportional, then directly. Inversely, then inversely. Okay, but you must make sure must touch the y-axis. Okay, your graph must touch the y-axis. Okay, which means you must extend the graph. The graph can be longer until it cuts the y-axis. Please make sure it cuts. Okay, then decrease linearly, you all know how it looks like. Straight line, yeah, linear means straight line, negative gradient. It is. All these curve, I don't think you will need this year, but increases with means it goes up. Okay, or it can go up like this also can. Decreases with, that means it goes down. Or it goes down like that also can. Lastly is inversely proportional. So like this. The graph don't touch the axis for inversely proportional. Huh? Okay, so that is the difference between that one and the decreases with graph. Decreases with can touch the axis, but inversely proportional cannot. And also, you don't just put your answer directly proportional to what. You must state what is the y. What is directly proportional to what? For example, FB, directly proportional to depth. Must write what is the y, what is the x. You can use symbol. Okay. Next part, I don't think so they will ask you gradient this year, but let's say if they ask, this is how you do it. Why I say most likely won't have gradient is because the gradient don't really have a meaning to it. Like it doesn't represent any physical quantity, but still they can ask right? Sometimes maybe they ask. So as long as you make sure you have units, I don't think anyone have problem finding gradient. Just make sure you don't forget you must have units. Yeah, because in maths, normally you all don't have unit one for your gradient. Yeah, so just take the y over the x. For example, it could be like Newton divided by cm. Then your unit is Newton per cm, for example. Yeah, and anytime it comes to doing your gradient, you must have minimum 4 box. You must draw a triangle. Draw a triangle that is as big as possible. Maybe you can use this 0, 0. Some of you will ask, teacher, but no, I want to do as big as possible. Oh, sorry. But it looks like my graph only have this point that is quite nice. Then it will make my triangle quite small. Well, then use any other point. It could be here. It could be here. Any point on the line. Can you use all these floating points? Don't. Guys, you're finding gradient of what? Gradient of the line. Okay, of that line. So you don't go and find the gradient of that point. That point is not even on the line. Yeah. So you can create your own point. Or if it's a nice point, you can use the one from your result. No problem. Okay. Just make sure to draw the triangle. And then you write out what coordinate you're using. Then you just do. Okay. Then you remind yourself, you put the unit together. Then you won't forget. Hello? Okay. Operational definition. I don't think so. You will get asked also, operational definition. I know normally you are quite worried about this operational definition, how to write. Just relate to the RE. Or relate to whatever you get from your experiment. For example, if you are doing the hacksaw blade with the plasticine one. Okay, then it oscillate left, right, that one. Oscillate. Okay, so that is then you change the mass of the plasticine, and then you see how long does it take to oscillate, the period of oscillation. Okay, then you just say, they ask, what is the operational definition of inertia? You say inertia is the period of oscillation. Like that. Okay, let's say you do an experiment that has the YouTube. Then got different liquid and then different height difference here, let's say. Then they ask, state the operational definition. Or you say liquid pressure is the difference in height in the water column. Why this year I feel won't ask? Because how can I relate buoyant force to my RV, which is also buoyant force? Okay, so very unlikely lah. But if they do ask anything about operational definition, whatever you're doing operational, then just try to relate it to buoyant force. Okay, try to relate it to buoyant force. But I don't think so can ask. Not all experiment is suitable to ask operational definition. Like last year also not suitable. Okay. Then normally the last 1 to 2 marks, they will ask you, what will happen to the result, to the gradient, to the buoyant force if something. Then they ask you to explain. You just say, oh, will it increase? Will it decrease? Will it be unchanged? And if they ask to explain, you say why. Okay, normally the last 1 to 2 marks is like that. What will happen to the result, to the gradient? Okay. Then we straight away move to the example question in the next page. Your teacher did this with yours, is it? Huh? Exactly the same one. Okay. I feel it's this. I feel it's very likely this one. I don't think so there will be a spring balance. Just a guess. Yeah, just a guess. I don't think so there will be a spring balance. So you're required to study the relationship between depths of rod immersed. That sounds like your MV, the one that goes to your x-axis, and the buoyant force, which is your RV, that sounds like the y-axis. Okay. Now, guys, question can give you any object lah. Yeah, silicon rod, steel rod. I heard it might be a candle. I don't know. Candle, then candle. Okay, question can give any object. You just follow it. Yeah, so you look at the list of apparatus, you don't say, where's the rod? Why don't I have rod? It might not be a rod, huh? Just follow the question. Okay. Now let's do the inferences. We go and write. Use the keyword depends on. You write yourself. Yeah. What depends on what? Okay. The buoyant force depends on the depth of rod immersed. Then the hypothesis is to make a smart guess. What do you think is the outcome of the experiment? Well, I think it's the greater relationship, because I look at it like this. How much I submerge will affect to will be related to the volume displaced. Or you can think of it as the volume submerged. Yeah, how much the depth of rod immersed is related to how much you submerge. And if you submerge more, it means this V will increase. And so should the buoyant force increase. Okay, so don't write directly proportional here. Don't. Just stick to greater or increase. Okay, very easy lah. Then you fill up the manipulated responding. So if it's rod, I write rod. If it's steel bar, I write steel bar. If it's candle, I write candle. Or it could be a long eraser, then I write eraser. Whatever it is lah. I don't think so it'll be plasticine. Okay. And then guys, right, I think you should have a habit of putting, if you know the symbol, because the question they are already giving you the H, the FB, you put at the side. H, FB. All these symbols are the one you can use in your graph, are the one you can put in your table also. Okay. Fixed variable. Best answer. Density of water. Density of liquid can. Density, because you're just using water. Water, liquid can. Find something that can directly affect buoyant force. Some they ask, teacher, can I write volume of water? Does the volume of water affect the buoyant force? No. Those of you who sat for Selangor trials, you know it doesn't affect. It doesn't affect. What affects buoyant force? How much you submerge. Right? So this water could be 1,000 liter, 1,000 milliliter. It doesn't matter. 800. It doesn't matter. It's how much submerged. Okay. So best answer is this. The thing that directly affects buoyant force. Yeah, density. Okay, next page. Later I teach you how to write the unguided procedures, but for now, they say carry out the experiment using the steps. Fill up the 70 ml in the measuring cylinder. So 70 ml could be another value. Maybe exam can ask you 100. Yeah, maybe they ask you 200, etc. It doesn't matter the volume. It doesn't matter. Record it as VO. Guys, 1 ml is how many cm cube? 1 ml is 1. Yesterday got some people don't know. Very scary. So 70 ml means 70 cm cube. Yeah. Okay. So that is, you go and put 70 ml of water. This question, put 70 ml, but it could be 100, 200, like I said. Okay. You have a huge measuring cylinder and you can dip this object. Okay. You can dip this object. Now in step 2, they say measure the length of silicon rod, or it could be candle, whatever. Measure the length of the silicon rod. This is so that you can know to know the depth. Okay, to know the depth immerse. And also, SPM might not have the ABCD. Okay, you see on this silicon rod already labeled ABCD. SPM might not have ABCD labeled. Okay, what I feel will happen is you might get an object, a long object that has reading on it. Okay, if don't have reading, then how? Then you use your ruler. If don't have reading, or else you use ruler to measure and you mark yourself. Maybe you can mark the depth H as 2 cm, 4 cm, etc. These are just example values. If the object is very short, then maybe 1 cm, 2 cm, 3 cm, 4 cm. If the object is very long, then maybe you can afford to do 2, 4, 6, 8, 10. You see, you pandai, just make sure you have 5 readings minimum. So if got the reading for you, very easy. You just submerge. If don't have, you just put your ruler and you measure. Okay? Or the worst case is like your Amali in during your trials. Those of you who sat for it, Selangor. You can take the ruler to the plasticine. That's one way to have measurements on the plasticine. Can also. Okay? So got many ways we can ask you. Then tie the silicon rod using a thread. If don't have thread, then they might use string same stuff. Okay, hang it on the retort stand. Okay, then you put it at level A. Well, it might not be called level A. It might be, the question might say, put the silicon rod until the depth of the rod submerged. In water, H equals to 2.0 cm. Okay, so it might be level A. We don't know whether there is levels, or they might say like this. Okay, then calculate the volume displaced by taking final volume minus initial volume. So after you submerge the silicon rod, the volume will increase. Yeah, the volume will increase. Final volume, initial volume, you minus. That is volume displaced. Then you repeat again the steps. Okay, so your repeating step could sound like this also. Repeat steps. Okay, you know what? I think I give you an unguided procedure to write. Wait. First point, you can write fill the water until 70 ml in the cylinder. Record as VO. Okay, step 1. Can be 100 ml also 200. You see how big is your cylinder. about half the measuring cylinder. Okay, don't want too much, don't want too little, because you submerge, it might pour out. Okay, about half, that'll be good. Then, so that's number one. Number two, you can write this straight away, tie the silicone rod using a thread and hang it to a retort stand. Okay. Number three, you can write this. Put the silicone rod in the water until the depth of rod submerged in water is that. Record the final volume, VF. Number four, calculate the volume displaced. Okay, you don't have to say record in the table, don't need. Then you add. Then calculate the buoyant force, FB, with the formula FB equals to rho VG. Okay, that's number four. Last step, repeat steps 3 and 4. For the depths of rod submerged. It could be rod or candle, doesn't matter, whatever the object. Okay, you write it like this. You see, I'll write depth of rod submerged in water, H, and then I write the value 4.0, 6 point, all this example only lah. Okay, it can be 1, 2, 3, 4, 5 cm, or 5, 10, 15, 20, 25 cm, 2, 4, 6, 8, 10 cm. Okay, it is a little bit long, but I tell you where is the important steps to get marks. You will get marked in step number 3. 1 mark. Because that's when you fix the first manipulated variable. You say, I want to submerge until H equals to 2. You will get another mark here, because that's how you get your RV, responding variable. You get another mark here, because that's where you repeat your experiment for 4 other values. Does it mean I don't need to write number 1, number 2? I think still need lah. Or else the story is not complete. No? Yeah, so the first 2 steps is just for setting up everything. Yeah, you don't get marked, but it completes the whole story lah. So you better write. Okay. So if unguided, you write like that. 1, 2, 3, 4, 5. Good enough. Okay, you don't have to say record in table or that. Don't need. And then next page, they will ask you to calculate it. Okay, huh? Okay, it's very nice. They give you the density, 1 gram per cm. Quick question, 1 gram per cm is how many kg per meter? What do you say? Per meter cube. It is 1,000. You might think, hey, teacher, but all these are so big. Why, if it's kg per meter cube, why is it so big now? Yeah, it is very big because you divide by meter cube. Okay, so 1 gram per cm cube is the same thing as 1,000 kg per meter cube. Also another thing, 9.81 Newton per kg is the same thing as 9.81 meter per second squared. Same. So I could give you the meter per second squared. I can give you the Newton per kg. If you forgot how to get Newton per kg, you just divide. You will get Newton. Okay, sorry. Weight is Newton per kg. Okay. Okay. Another thing, Just now we dealt with 1 ml. 1 ml is 1 cm cube. Okay. And I hope you all know 1 liter is 1000 ml. Okay. Right. But the harder one is 1 meter cube is how many cm cube? Six zeros. Did anyone say 100? Did anyone say 100? If you're saying 100, you know what's the issue? Yeah, 1 meter is 100 cm, but you go and cube it lah, please. You get 1 cube, 1 meter cube. Okay, 1 cube is just 1, but 100 cube is 1 million. Got 6 zeros one. Okay, so you might need this. I do not know. You might need this. And then last but not least, this one I think don't need to write. So can 1 kg is 1000 grams. Yeah, if you don't know this, you don't need to sit for physics. Okay, then we calculate the buoyant force. I'm going to put down some example values. Again, these are just examples. Okay. Let's say my depth that I got 2.0, 4.0, 6.0, 8.0, 10.0. Your SPM paper maybe got the label A, B, C, D, E. Maybe don't have. I don't know. Yeah, so don't have, that means you just follow this. Then you got your final volume as, let's say, let me do wait, 88.0, 106.0, 124.0, 142.0. Again, these are just examples. Lastly, 160.0. Okay, let's not forget to find the volume displaced. I take the final volume minus the initial. The initial that this experiment used was 70 ml or 70 cm cube. If you use 100, then you minus differently. So you take 88 minus 70, then you get your 18. Okay, you take 106 minus 70, you get 36, for example. 124 minus 70, then you get 54, let's see. All the numbers minus 70, yeah? So you follow your experiment. It could be 70, it could be 100. Last one is 90. Okay, then you go and try to find the buoyant force. Your formula is rho times V times G. Density, I follow the question, 1 gram per cm cube. Volume, mine is 18 cm cube. Then 9.81 Newton per kg is the G. Do you think this can give you the answer in newtons? So I'm just multiplying everything I got. You double check for me. Do you think this can be in newtons? Cannot. What's the problem? The gram and the kg cannot cancel. So like this. That's why I purposely write down all the units. Just that when you multiply, be a bit careful, because I might not be able to cancel the units. Then you do some unit conversion. So cm cube, very nice, can cancel. Gram and kg cannot cancel. I cannot get Newton. Cannot. So let's do something about this kg. Maybe I change this kg to gram. Okay, I put kg up here so that kg can cancel. Kg and gram is related. You just put down the conversion. 1 kg is 1000 grams. If kg is down there, you want to cancel kg, put kg up. If not, then it's terbalik lah. Just make sure one up, one down to cancel. Cancel them. Could be like this, could be like that. Now you can get answer. Okay. It is actually a very small value, 0.17658 Newton. Okay, so long my number, this number. But in your table, you just put one more decimal only, 0.18 Newton, let's say. Good enough. And please calculate for the rest, please. So you do everything the same, you just replace this number to 36. Oh yes, you don't need the n there, because the Newton already up here. Okay, actually don't need to write Newton again. But careful in your table, you must have all the units. Okay, careful, must have units. I know I said this many times already, but this is the place where people lose marks. Same decimal places, please. Okay, so after doing everything, go back and check all your table must have two things. Your table must have the same decimal place, must have units. Okay, after you finish your whole paper, you check one round. Table, check all the units are there. Go and look at your graph, make sure the units are at the axis. That will be your final round of checking. Remember units. Don't lose up. It'll be a waste if you lose that. Okay, last one. Okay, done. This one didn't ask us to draw graph, so you can go and plot your graphs as usual. This table might cost 4 marks, 5 marks, right? Or if they're stingy, then 3. Based on your calculation, state the relationship between buoyant force and the depth. Okay, we most likely will get the directly proportional shape. You right lah. FB is directly proportional to, remember it's the responding variable first, the y-axis first, to h. Can use symbol or not? Can. Okay. Because you are in your graph also, you just use the symbol. If you are paranoid, then you write in words. So. Okay. Can you state one precaution? I think there's only one for this. The parallax error one, right? Ensure eye level is what? What's that word? Perpendicular, not parallel. Perpendicular to the scale. So why do we say perpendicular? Because your measuring cylinder is like this, right? Your measuring cylinder is like that. And then you want to make sure that your eye level is 90 degrees to the measuring cylinder. Okay. So ensure eye level, something like this is perpendicular. Cannot write increase. Cannot. Pro. Oh, your paper confirm will have graph. Sorry, I just realized I spelled proportional wrong. Cannot write the greater, the greater. Your paper will have graph. Cannot write greater, greater here. I feel only two acceptable answer. If your graph look like increase linearly, then increase linearly. If your graph is directly proportional, then directly proportional. Your answer has to come for the graph part, because your one confirm will have graph. Your answer must come from this list. Okay, the one in page 1, directly proportional. This year, your focus is this two lah. I feel your experiment will either be one of these. Okay. If it's not directly proportional, you just try to connect to the origin, to the point O also okay one. Yeah, you should get directly proportional. Okay, if some values are really too chat, then smart a bit lah. Maybe you can adjust. Who knows? Who will know what is your reading? Okay. Do you think they care the reading? They care about the reading? Not really. As long as it looks quite logical, and as long as there is an increasing trend. As long as there's an increasing trend. So as long as it doesn't drop below the previous value, increase all your values in the table correct. Remember, this is paper 3, not paper 2. Yeah, it's perpendicular to the scale of the measuring cylinder. Yeah, to avoid parallax error, correct. Yes, Joseph? Need to write what? Ensure eye level is perpendicular to the scale. Cannot write scale, need to write reading. I have never heard anything like that, but I can double check. So far scale, there's nothing wrong. Yeah, no problem. Okay. I don't know lah. Maybe in a small case, if it's not a measuring cylinder, then you replace this word with other things, right? Maybe you're using I don't know, a beaker or whatever. I don't know lah. I don't know. Then change the word lah. Be flexible a bit. Okay. Predict the change in volume of the liquid displaced if water is replaced with seawater. So yeah, seawater can be salt water also. Yeah, which has a higher density. Will the volume of liquid displaced change? No. If it's buoyant force, then yes. Yeah. If it's buoyant force, then yes. Okay. Someone asked, for precaution, you can write, take 2 readings and find the average. Can also. You can also say, repeat the experiment 3 times and find an average value, so that reading is more accurate. Can also. Okay. But I think the skill one is the best. The eye level one is the best. Okay. How come doesn't affect the liquid displaced? You think like this. You change the water, but did the depth change or not? You still submerge to the same depth, right? So the volume shouldn't change, right? I'm gonna write D is unchanged or has no change. Okay, what's the reason? Because depth of rod immersed is unchanged. As long as you never immerse more, why would the volume change? Volume lah, huh? But I feel the more probable question is not on volume. They'll ask you on buoyant force most likely. Predict the change to buoyant force or gradient. Gradient also can. If replace with seawater? Explain. Okay, I feel this is the more probable question. Then you write, what will happen? This one will increase. Okay, this one will increase. Both gradient or FB, both also will increase. Reason? The density is greater. Seawater has higher density. Okay, so the graph will look like this lah. At first, the one that you drew looks like this. Okay, the one that you drew is like this. This is the original one, let's say. Okay, it just means that if you go and change it to seawater, all the values will have a higher buoyant force. You submerge all to the same depth, the depth all the same, but all of it will have a bigger buoyant force. This is for seawater. I hope you know the answer lies here. So V is fixed, G is fixed. You are submerging the same depth, but you increase the density, FB will increase. Okay, it could be a K-bar question also. What if I replace the water with oil? Then density lower lor. Okay, so we'll be smart lah. If it's oil, then it's less dense. Okay, if it's oil, then it's less dense. Then FB will decrease lah. Okay, so it could be both. Can you say gradient is steeper? If the graph is a graph that is going up, right? I feel you should just say increase. Yeah. It's nothing wrong to say steeper. Nothing wrong. But if you ask me, I would prefer increase. The number will increase. Okay. I also included for those of you who did not sit for the Selangor one, I also included this for you. This is another experiment for Selangor trials this year, whereby they use a spring balance. Okay, they use a spring balance and then they emerge. You can go and read through a little bit again. Okay, you can go and read through a little bit. So the part that I feel I want to talk about is this one. How do they get the buoyant force? Just a quick one. So, reminder, in order for you to get the buoyant force, you take the weight of plasticine. This one is emerging, the plasticine, minus reading of spring balance. Reading of spring balance is also known as the apparent weight. Okay. Basically, buoyant force is how much weight loss. At first, the plasticine, let's say 5 Newton. You submerge in water, become 4.8 Newton already. The weight loss, FB, is 0.2. Understand? So for this kind of question is reading from the spring balance one. I don't think so you will get a spring balance. But it's good to know more, to read. Okay, and then state one observation using about the spring balance reading if the depth increase. Okay, so for your paper, maybe they don't ask reading of spring balance. They can ask reading of reading on measuring cylinder, let's say. For example, okay, they can ask you on the reading of the measuring cylinder, what will happen if you submerge more? Measuring cylinder increase will give you more reading, right? This one quite obvious. It does look like the whole table looks very perfect, but there is something that you cannot see because everything is in black and white, and that is this 0 actually. This student actually forgot to put the 0.0. That's why the whole table is right and this person lost a mark. Because it's in red color. Actually, the one is the teacher right one. It's the 0.0. You forgot the 0.0. The decimal place is no longer consistent. Yeah. So this person got 14 out of 15 for that 0.0. Very cruel. Huh? That's why very easy to lose marks. Very easy to get marks also. Very easy to lose marks as well. Okay. Then next one. This is the same stuff. If you replace the water with salt water, FB increase, gradient increase. If you increase the volume to 1000 ml, gradient unchanged. Guys, how to see whether or not it will affect the buoyant force or the gradient? Remember, as long as the density or the volume never change, buoyant force will not change. Okay, so they can ask K-bar question. I can change 1001 things. It doesn't matter. Just double check the formula. As long as the density of water never change, the liquid never change, or the V never change. So V doesn't always have to sound like volume. How much you submerge also will affect the V. Yeah, how much you submerge in. You change the volume of water, but then you submerge the same amount. It will not change. Right? The buoyant force does not change, the gradient does not change. Just follow this formula. Okay, lastly, you look at this graph, even though it looks like it's quite small, this graph, but this is the best that this student could do because the graph is a bit more than 50%. 50% is here. This is already a bit more than 50%. So good enough. It's okay. And yeah, because of this value is 2 point something. If you change the scale to, guys, can I use a scale of 0.41 box? What do you think? Not recommended. Not recommended. As long as if you try to divide 0.4 by 10 and it gives you a very weird reading for that one small box, if it's a weird reading, then don't use. So 0.3 also don't want. I have a feeling your one will most probably be like maybe a 0.2, 0.4, 0.6, that kind. Okay, or it could be a 0.1, 0.2, 0.3, and so on, so on, so on. It won't be very big. Or it could be maybe a bit bigger, 0.5, 1.0, and so on. I feel it's not going to be a huge value. It's going to be a small one like this. Okay. Guys, if they didn't label the axis, if they just give you a blank graph paper, you can draw portrait or landscape one. Okay, if they didn't label, you can turn your paper and draw portrait or landscape. If they didn't draw the axis ready for you, if it's just a blank graph paper, then can. Okay, or else then you follow. Or else then you follow. Okay, that is the end of your paper 3. I think quite okay chill this one. But you read a bit other things. Read through the textbook one also maybe. Yeah. Okay. We will take. We take a break.